Coulomb.
The coulomb is a fundamental unit of electrical charge, and is also the SI-derived unit of electric charge. It is equal to the charge of approximately 6.241 x 1018 electrons. Its SI definition is the charge transported by a constant current of 1 ampere in 1 second. 1 coulomb is also the amount of excess charge on a capacitor of 1 farad charged to a potential difference of 1 volt.
Name and notation.
This SI unit is named after Charles Augustin de Coulomb. As with every international system of units, SI unit whose name is derived from the proper name of a person, the first letter of its symbol is uppercase, C. However, when an SI unit is spelled out in English, it should always begin with a lowercase letter, Coulomb, except in a situation where any word in that position would be capitalized, such as at the beginning of a sentence or in capitalized material such as a title. Note that degree Celsius conforms to this rule because the D is lowercase. Based on the International System of Units, Section 5.2.
Definition.
In the SI system, the coulomb is defined in terms of the ampere and second, 1 farad equals 1 AX 1 second. The second is defined in terms of a frequency which is naturally emitted by cesium atoms. The ampere is defined using Ampere's force law. The definition relies in part on the mass of the international prototype kilogram, a metal cylinder housed in France. In practice, the watt balance is used to measure amperes with the highest possible accuracy. Since the charge of 1 electron is known to be about 1.60217657 x 1019 coulombs, a coulomb can also be considered to be the charge of roughly 6.241509324 x 1018 electrons, or protons, the reciprocal of 1.60217657 x 1019.
SI prefixes.
See also SI prefix.
Conversions.
The magnitude of the electrical charge of 1 mole of elementary charges, approximately 6.022 x 1023, or Avogadro's number, is known as a Faraday unit of charge, closely related to the Faraday constant. 1 Faraday equals 96,485.3399 coulombs. In terms of Avogadro's number, Na, 1 coulomb is equal to approximately 1.036 x Nax 10. 5 elementary charges, 1 ampere-hour equals 3600 C, 1 megampere. H equals 3.6 C. The elementary charge is 1.6021764887 x 1019 C. 1 stat coulomb, stat C, the obsolete CGS electrostatic unit of charge, SU, is approximately 3.3356 x 1010 C, or about 1/3 of a nanocoulomb. 1 coulomb is the magnitude, absolute value, of electrical charge in 6.241509651 x 1018 protons or electrons.
Relation to elementary charge.
The elementary charge, the charge of a proton, equivalently, the negative of the charge of an electron, is approximately 1.6021764887, 40, x 1019 C. In SI, the elementary charge in coulombs is an approximate value, no experiment can be infinitely accurate. However, in other unit systems, the elementary charge has an exact value by definition, and other charges are ultimately measured relative to the elementary charge. For example, in conventional electrical units, the values of the Josephson constant Kj and von Klitzing constant Rk are exact defined values, written Kj90 and Rk90, and it follows that the elementary charge E equals 2/Kj/Rk, is also an exact defined value in this unit system. Specifically, E90 equals opening round bracket 2 times 10 9 slash 25,812.807 x 483,597.9 C exactly. SI itself may someday change its definitions in a similar way. For example, One possible proposed redefinition is the ampere is such that the value of the elementary charge E, charge on a proton, is exactly 1.60217648 x 10^19 coulombs. This proposal is not yet accepted as part of the SI. The SI definitions are unlikely to change until at least 2015.
In everyday terms,
The charges in static electricity from rubbing materials together are typically a few microcoulombs. The amount of charge that travels through a lightning bolt is typically around 15 C, although large bolts can be up to 350 C. The amount of charge that travels through a typical alkaline AA battery from being fully charged to discharged is about 5 kC equals 5000 C. 1.4 A. H. According to Coulomb's law, two negative point charges of 1 C, placed 1 meter apart, would experience a repulsive force of 9x109 N, a force roughly equal to the weight of 920,000 metric tons of mass on the surface of the Earth. The hydraulic analogy uses everyday terms to illustrate movement of charge and the transfer of energy. The analogy equates charge to a volume of water, and voltage to pressure. 1 coulomb equals the negative of the charge of 6.24 x 1018 electrons. The amount of energy transferred by the flow of 1 coulomb can vary. For example, 300 times fewer electrons flow through a lightning bolt than through an AA battery, but the total energy transferred by the flow of the lightning's electrons is 300 million times greater.